An electrical panel should have a main breaker to protect the entire circuit. A panel with more than 6 breakers without a main is a violation of the National Electrical Code, or NEC. The presence of 15 amp breakers with 2 wires on them indicates that they are likely connected to neutral conductors, which is a violation of proper wiring practice. The total amperage of the breakers on each phase should not exceed the panel's capacity. In this case, phase B has a total of 90 amps of breakers. While that number is below the 100 amp panel rating, it is worth investigating if this situation is a code violation depending on how the loads are used in the apartment. The first problem is the missing main breaker. The panel should have a main breaker to protect the entire circuit. Without a main breaker, there's no single point to disconnect power to the entire panel in case of an emergency or for maintenance. The second problem is overcrowding. The panel has more than 6 breakers without a main, which is a violation of the National Electrical Code, or NEC. The 6-breaker rule is in place to limit the number of circuits controlled directly by the main disconnect. Without a main breaker, the individual branch circuits are not properly protected. The third problem is incorrect wiring. The 15 amp breakers with 2 wires on them indicate that they are connected to neutral conductors, which is a violation. This situation could lead to overloading of the neutral conductor and potential safety hazards. The fourth problem is exceeding capacity. The total amperage of the breakers on each phase should not exceed the panel's capacity of 100 amps. Although one phase is at 90 amps, which is technically under the limit, it's crucial to consider the potential for overload if all circuits are used simultaneously. Firstly, there is the missing main breaker. The purpose of a main breaker is to serve as a primary overcurrent protection device for the entire electrical panel. It acts as a safeguard against excessive current flow, which could result from short circuits, overloads, or other electrical faults. When the current exceeds the main breaker's rating, it trips, interrupting the power supply to the entire panel. This prevents damage to the electrical system, reduces the risk of fire, and protects individuals from electrical shock. Secondly, it protects against overcurrents. Overcurrents can occur due to various reasons, such as short circuits, ground faults, or excessive loads on the circuits. Without a main breaker, these overcurrents can flow unchecked through the panel, potentially causing severe damage to the wiring, appliances, and other electrical components. Thirdly, it allows for easy disconnection. The main breaker provides a convenient way to disconnect power to the entire panel for maintenance, repairs, or emergencies. By simply switching off the main breaker, electricians or homeowners can safely work on the electrical system without the risk of electrical shock or other hazards. Fourthly, it provides code compliance. Most electrical codes require the installation of a main breaker in electrical panels to ensure safety and proper operation. Compliance with these codes is essential to prevent electrical hazards and to meet insurance requirements. The 6-breaker rule is a provision in the National Electrical Code, or NEC, that limits the number of overcurrent devices in a panel board without a main overcurrent protective device. The rule states that a panel board used as service equipment shall have a main overcurrent protective device located within or immediately adjacent to the panel board. However, the rule permits up to 6 overcurrent devices to serve as the overcurrent protection for the panel board if certain conditions are met. Firstly, there is overcurrent protection. The main purpose of the 6-breaker rule is to ensure that each circuit within the panel board is adequately protected against overcurrents. By limiting the number of overcurrent devices, the rule helps to prevent overloading of the panel board and reduces the risk of electrical fires or other hazards. Secondly, there is simplified disconnection. The 6-breaker rule also simplifies the process of disconnecting power to the panel board in case of an emergency or maintenance. With a limited number of overcurrent devices, it is easier to quickly identify and switch off the appropriate breakers to energize the panel. Thirdly, there is compliance with the NEC. The 6-breaker rule is a specific requirement outlined in the National Electrical Code, or NEC. Compliance with this rule is essential for ensuring the safety and proper functioning of electrical systems. It is also necessary for meeting regulatory requirements and passing electrical inspections. The neutral conductor is a critical component of electrical systems. It serves as the return path for electrical current from the load back to the source. In a properly functioning electrical system, the neutral conductor carries only the unbalanced current between the hot conductors. However, there are situations where the neutral conductor can become overloaded, leading to potential safety hazards. Firstly, there is unbalanced loading. In multi-wire branch circuits, the neutral conductor carries the unbalanced current between the hot conductors. If the loads on each hot conductor are not evenly distributed, the neutral conductor may carry a significant amount of current. Secondly, there are harmonic currents. Nonlinear loads, such as electronic devices, can generate harmonic currents that flow through the neutral conductor. These harmonic currents can add up and cause the neutral conductor to become overloaded, even if the fundamental current is within the rated capacity. Thirdly, there are shared neutral conductors. Sharing a neutral conductor between multiple circuits can also lead to overloading. If the combined current from all the circuits exceeds the neutral conductor's capacity, it can overheat and potentially cause a fire. Fourthly, there are loose connections. Loose connections in the neutral conductor can create resistance, causing the conductor to heat up and potentially fail. This can also disrupt the flow of current and cause voltage fluctuations in the electrical system. The total amperage of the breakers on each phase should not exceed the panel's capacity of 100 amps. This is because the panel's capacity represents the maximum amount of current a panel is designed to safely handle. Exceeding this capacity can lead to overheating, damage to the panel components, and potentially even electrical fires. Here's why it's important to adhere to the panel's capacity. Firstly, there is safety. Exceeding the panel's capacity can create a dangerous situation, increasing the risk of electrical fires, equipment damage, and electrical shock. Secondly, there is equipment protection. The panel's components, such as breakers and busbars, are designed to handle a specific amount of current. Exceeding this limit can cause them to overheat and fail, leading to costly repairs or replacements. Thirdly, there is code compliance. Electrical codes mandate that the total amperage of the breakers on each phase does not exceed the panel's capacity to ensure safety and proper functioning of the electrical system. Violating this requirement can result in code violations and potential fines. Fourthly, there is system reliability. Overloading the panel can cause voltage drops and other electrical problems, leading to unreliable performance of connected equipment and appliances. In this specific scenario, the electrical panel setup is unsafe and does not meet code requirements. It is strongly recommended to upgrade to a larger panel with a main breaker and proper wiring. Firstly, a larger panel provides more space and capacity for additional circuits, accommodating future electrical needs and reducing the risk of overloading. Secondly, a main breaker offers a single point of disconnect for the entire panel, enhancing safety during maintenance or emergencies. Thirdly, proper wiring ensures that all circuits are correctly installed and connected, minimizing the risk of electrical hazards such as short circuits or ground faults. The upgrade will ensure safety and prevent potential electrical hazards. These hazards include firstly electrical shock. Exposed or improperly wired electrical components can pose a risk of electrical shock to individuals who come into contact with them. Secondly, electrical fires. Overloaded circuits, loose connections, or damaged wiring can lead to electrical fires, which can quickly spread and cause significant damage to property and endanger lives. Thirdly, equipment damage. Voltage fluctuations and power surges caused by electrical hazards can damage sensitive electronic equipment and appliances, resulting in costly repairs or replacements. The upgrade also reduces the risk of firstly, code violations. Non-compliance with electrical codes can result in fines, penalties, and legal liabilities for homeowners or building owners. Secondly, insurance issues. Insurance companies may refuse to cover damages caused by electrical hazards if the electrical system is not up to code or properly maintained. Thirdly, liability. Property owners can be held liable for injuries or damages caused by electrical hazards on their property, especially if they were aware of the hazards and failed to take corrective action. Here's a more in-depth look into the specific violations and the recommended solutions. The missing main breaker. Firstly, the violation is the absence of a main breaker. The NEC requires a main breaker in most residential electrical panels to provide overcurrent protection for the entire panel. Secondly, the hazard is that without a main breaker, there's no easy way to shut off power to the entire panel in case of an emergency or for maintenance. Thirdly, the solution is to install a main breaker that is rated for the capacity of the panel. This will provide overcurrent protection and a convenient shut-off point. Overcrowding. Firstly, the violation is too many breakers in the panel. The NEC limits the number of breakers in a panel based on its design and listing. Secondly, the hazard is that overcrowding can lead to overheating and difficulty in safely working on the panel. Thirdly, the solution is to either install a larger panel with more breaker spaces or remove some of the existing circuits. The NEC provides guidelines on how to calculate the load on each circuit to ensure that the panel is not overloaded. 15 amp breakers on neutrals. Firstly, the violation is using 15 amp breakers on neutral conductors. This is a dangerous and incorrect wiring practice. Secondly, the hazard is that it can cause the neutral conductor to become overloaded, leading to overheating and potentially a fire. Thirdly, the solution is to rewire the circuits correctly, ensuring that each circuit has its own dedicated neutral conductor. The neutral conductor should be sized appropriately for the circuit's load. Sizing. Firstly, the violation is potential overload on phase B. Although the total amperage of the breakers on phase B is slightly below the panel's capacity, it's still a concern if all circuits are loaded simultaneously. Secondly, a hazard is that overloading can cause the breakers to trip frequently and can also damage the panel and connected equipment. Thirdly, the solution is to calculate the actual load on each phase and ensure that it does not exceed the panel's capacity. If necessary, redistribute the loads between the phases or upgrade the panel to a higher capacity. Additional considerations. Firstly, grounding and bonding. Ensure that the grounding and bonding system is properly installed and maintained. This is essential for safety and for preventing electrical shock. Secondly, GFCI protection. Install GFCI, or ground fault circuit interrupter, protection in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Thirdly, FSI protection. Install FSI, or arc fault circuit interrupter, protection on branch circuits that serve bedrooms and other areas where there is a high risk of arc faults. Finally, professional inspection. Have a qualified electrician inspect the electrical system to ensure that it is safe and up to code. They can identify any potential problems and recommend appropriate solutions. Upgrading the electrical panel is a significant investment, but it is essential for safety and for protecting your home and family. By addressing the electrical panel violations and following the recommendations outlined, you can ensure that the electrical system is safe, reliable, and up to code. Remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to perform the upgrade and any necessary repairs. This will ensure that the work is done safely and correctly, and that your electrical system meets all applicable codes and standards. In conclusion, the current electrical panel setup poses several safety hazards and code violations. It is imperative to address these issues promptly to prevent potential electrical fires, equipment damage, and personal injury. Upgrading to a larger panel with a main breaker, correcting the wiring errors, and ensuring proper grounding and bonding are essential steps to take. Additionally, it is crucial to have a qualified electrician inspect the electrical system to identify any other potential problems and ensure that all work is performed in accordance with applicable codes and standards. Ignoring these violations can have serious consequences, including fines, insurance issues, and liability for injuries or damages caused by electrical hazards. By taking proactive measures to address these issues, you can protect your home, your family, and yourself from the dangers of electrical malfunctions.